Being a general-purpose language, it can be used to build almost any type of application with the right tools, libraries. Additionally, Python supports objects, modules, threads, exception handling and automatic memory management which help in modeling real-world problems and building applications to solve these problems. 2. What are the benefits of using Python? Python is a general-purpose programming language that has simple, easy-to-learn syntax which emphasizes readability and therefore reduces the cost of program maintenance. Moreover, the language is capable of scripting, completely open source and supports third-party packages encouraging modularity and code reuse. Its high-level data structures, combined with dynamic typing and dynamic binding, attract a huge community of developers for rapid application development and deployment. 3. What is a dynamically typed language? Before we understand what a dynamically typed language, we should learn about what typing is. Typing refers to type checking in programming languages. In a strongly typed language, such as Python, 1 plus 2 will result in a type error, since these languages don't allow for type coercion, implicit conversion of data types. On the other hand, a weakly typed language, such as JavaScript, will simply output 12 as result. Four. What is an interpreted language? An interpreted language executes its statements line by line. Languages such as Python, JavaScript, R, PHP, and Ruby are prime examples of interpreted languages. Programs written in an interpreted language runs directly from the source code, with no intermediary compilation step. 5. What is PEP8 and why is it important? PEP stands for Python Enhancement Proposal. A PEP is an official design document providing information to the Python community or describing a new feature for Python or its processes. PEP8 is especially important since it documents the style guidelines for Python code. Apparently, contributing in the Python open source community requires you to follow these style guidelines sincerely and strictly. 6. How is memory managed in Python? Memory management in Python is handled by the Python Memory Manager. The memory allocated by the manager is in form of a private heap space dedicated for Python. All Python objects are stored in this heap and being private, it is inaccessible to the programmer. Though Python does provide some copy functions to work upon the private heap space. Additionally, Python has an inbuilt garbage collection to recycle the unused memory for the private heap. 7. What are Python namespaces? Why are they used? A namespace in Python ensures that object names in a program are unique and can be used without any conflict. Python implements these namespaces as dictionaries with name as key, mapped to a corresponding object as value. This allows for multiple namespaces to use the same name and map it to a separate object. A few examples of namespaces are as follows. Local namespace includes local names inside a function. The namespace is temporarily created for a function call and gets cleared when the function returns. Global namespace includes names from various imported packages, modules that is being used in the current project. This namespace is created when the package is imported in the script and lasts until the execution of the script. Built-in namespace includes built-in functions of core Python and built-in names for various types of exceptions. Lifecycle of a namespace depends upon the scope of objects they are mapped to. If the scope of an object ends, the lifecycle of that namespace comes to an end. Hence, it isn't possible to access in a namespace objects from an outer namespace. Point 8. What is scope in Python? Every object in Python functions within a scope. A scope is a block of code where an object in Python remains relevant. Namespaces uniquely identify all the objects inside a program. However, these namespaces also have a scope defined for them where you could use their objects without any prefix. A few examples of scope created during code execution in Python are as follows. A local scope refers to the local objects available in the current function. A global scope refers to the objects available throughout the code execution since their inception. A module level scope refers to the global objects of the current module accessible in the program. An outermost scope refers to all the built-in names callable in the program. The objects in this scope are searched last to find the name referenced. Note: local scope objects can be synced with global scope objects using keywords such as global. 9. What is scope resolution in Python? A. Sometimes objects within the same scope have the same name but function differently. In such cases, scope resolution comes into play in Python automatically. A few examples of such behavior are: Python modules, namely math and cmath, have a lot of functions that are common to both of them, log10, acos, exp, etc. To resolve this ambiguity, it is necessary to prefix them with their respective module, like math.xp and cmath.xp. Consider the code below. An object temp has been initialized to 10 globally and then to 20 on function call. However, the function call didn't change the value of the temp globally. Here, we can observe that Python draws a clear line between global and local variables, treating both their namespaces as separate identities. 10. What are decorators in Python? A. Decorators in Python are essentially functions that add functionality to an existing function in Python without changing the structure of the function itself. They are represented by the @decorator underscore name in Python and are called in bottom-up fashion. Ten. What are decorators in Python? A. Decorators in Python are essentially functions that add functionality to an existing function in Python without changing the structure of the function itself. They are represented by the @decorator underscore name in Python and are called in bottom-up fashion. For example, 11. What are lists and tuples? What is the key difference between the two? A. Lists and tuples are both sequence data types that can store a collection of objects in Python. The objects stored in both sequences can have different data types. Lists are represented with square brackets, Sara, 6, 0.19, while tuples are represented with parentheses, Ansh, 5, 0.97. But what is the real difference between the two? The key difference between the two is that while lists are mutable, tuples on the other hand are immutable objects. This means that lists can be modified, appended or sliced on the go, but tuples remain constant and cannot be modified in any manner. You can run the following example on Python idle to confirm the difference. "12. What are dict and list comprehensions? Python comprehensions, like decorators, are syntactic sugar constructs that help build altered and filtered lists, dictionaries or sets from a given list, dictionary or set. Using comprehensions saves a lot of time and code that might be considerably more verbose, containing more lines of code. Let's check out some examples where comprehensions can be truly beneficial. 13. What are the common built-in data types in Python? There are several built-in data types in Python. Although Python doesn't require data types to be defined explicitly during variable declarations, but type errors are likely to occur if the knowledge of data types and their compatibility with each other are neglected. Python provides type and isinstance functions to check the type of these variables. These data types can be grouped into the following categories. What is Lambda in Python? Why is it used? A. Lambda is an anonymous function in Python that can accept any number of arguments, but can only have a single expression. It is generally used in situations requiring an anonymous function for a short time period. Lambda functions can be used in either of the two ways. Assigning lambda functions to a variable mul equals lambda a, b, a asterisk b print mul 2, 5, hash output equals greater than 10. Wrapping lambda functions inside another function of mywrapper n, return lambda a asterisk n mul 5 equals mywrapper, 5 print mul 5 2, hash output equals greater than 10. 15. What is pass in Python? A. The pass keyword represents a null operation in Python. It is generally used for the purpose of filling up empty blocks of code which may execute during runtime but has yet to be written. Without the pass statement in the following code, we may run into some errors during code execution. 16. How do you copy an object in Python? A. In Python, the assignment statement equals operator does not copy objects. Instead, it creates a binding between the existing object and the target variable name. To create copies of an object in Python, we need to use the copy module. Moreover, there are two ways of creating copies for the given object using the copy module. Shallow copy is a bitwise copy of an object. The copied object created has an exact copy of the values in the original object. If either of the values are references to other objects, just the reference addresses for the same are copied. Deep copy copies all values recursively from source to target object, i.e., it even duplicates the objects referenced by the source object. 17. What is the difference between xRange and range in Python? Xrange and range are quite similar in terms of functionality. They both generate a sequence of integers, with the only difference that range returns a Python list, whereas xrange returns an xrange object. So how does that make a difference? It sure does, because unlike range, xrange doesn't generate a static list, it creates the value on the go. This technique is commonly used with an object type generators and has been termed as yielding. Yielding is crucial in applications where memory is a constraint. Creating a static list as in range can lead to a memory error in such conditions, while xrange can handle it optimally by using just enough memory for the generator, significantly less in comparison. What are modules and packages in Python? Python packages and Python modules are two mechanisms that allow for modular programming in Python. Modularizing has several advantages. Simplicity: working on a single module helps you focus on a relatively small portion of the problem at hand. This makes development easier and less error-prone. Maintainability: modules are designed to enforce logical boundaries between different problem domains. If they are written in a manner that reduces interdependency, it is less likely that modifications in a module might impact other parts of the program. Reusability: functions defined in a module can be easily reused by other parts of the application. Scoping: modules typically define a separate namespace, which helps avoid confusion between identifiers from other parts of the program. Modules, in general, are simply Python files with a P extension and can have a set of functions, classes, or variables defined and implemented. They can be imported and initialized once using the import statement. If partial functionality is needed, import the requisite classes or functions using from foo import bar. Packages allow for hierarchical structuring of the module namespace using dot notation. As modules help avoid clashes between global variable names, in a similar manner, packages help avoid clashes between module names. Creating a package is easy since it makes use of the system's inherent file structure. So just stuff the modules into a folder and there you have it, the folder name is the package name. Importing a module or its contents from this package requires the package name as prefix to the module name joined by 19. What are global, protected and private attributes in Python? Global variables are public variables that are defined in the global scope. To use the variable in the global scope inside a function, we use the global keyword. Protected attributes are attributes defined with a underscore prefix to their identifier, e.g. underscore Sarah. They can still be accessed and modified from outside the class they are defined in, but a responsible developer should refrain from doing so. Private attributes are attributes with double underscore prefix to their identifier, e.g. underscore ansh. They cannot be accessed or modified from the outside directly and will result in an attribute error if such an attempt is made. 20. What is self in Python? Self is a keyword in Python used to define an instance or an object of a class. In Python, it is explicitly used as the first parameter, unlike in Java where it is optional. It helps in distinguishing between the methods and attributes of a class from its local variables.